If you already installed Magic, you can run it by typing its name in the search field. Let's open application. In this video, we will examine the functions of speech analysis module. Suppose that you have a video recording of an experiment and you want to annotate speech data collected during the experiment. If you make this annotation process manually, you will probably pause and listen video several times to specify and to take note of the interval, speaker, and the label of speech. Magic significantly reduces this effort and time necessary to annotate audio recording. It automatically segments the audio file in a couple of seconds and also provides an interface to facilitate the annotation of the audio segments. Let's run speech analysis process. We will perform analysis for the following pilot study. I want to show the representation of it in a figure. One of the participants was assigned the role of an interviewer and the other one is assigned the role of an interviewer randomly. Both participants wore Tobii monocular eye tracking glasses at a sampling rate of 30 Hz. Thus, at the end of each session, we ended up with multiple recordings belong to each participant. But you don't have to collect multiple recordings in a session to use Magic in your analysis. You can run your analysis for a single participant as well by using Magic. And also Magic is eye tracker independent, so you don't have to use Tobii eye tracker as well. As the first step, we can use extract and format audio panel to extract audio file from an input video file in an AVI format. This process is necessary for further Sphinx analysis. Sphinx requires 16 kHz, 16-bit mono, and little endian WAV files. To get instant help before performing the function, you can press Go to Walkthrough button, and it will open related walkthrough page. This page involves info, steps, and output subheaders, and also provide sample input text and sample file, links of sample files. If you have an internet connection, you can download sample file by clicking these links, and you can try all functions that I will talk about through this video by using these sample files and sample text. So now we can go back to the function by clicking Go to Function button. For extract and format audio panel, users have to enter two inputs. Firstly, user have to specify output folder where the formatted audio file will be saved under. And secondly, user also has to select a video file in an AVI format. Let's select an output folder. I will use this path through this video demo videos. Of course, you can select different paths, and I will select the audio file that I have already downloaded from the given link in the walkthrough page, data, videos, and this AVI file belongs to interviewer recording, and then click the convert button. It finishes immediately. Since in this pilot study there were two participants, I will repeat this function for the second participant, namely for an interviewee. This time the output folder will be same, but I will choose different AVI file which belongs to an interviewee, and then click convert button, and it also finishes immediately. This is the output folder. As you can see, we run the function twice and two different WAV files were generated under the outputs demo. This is the first part. If you have already extracted and formatted audio file, you can skip this panel and you can start directly from the second panel, which is segment audio. Segment audio panel offers an interface to segment the audio file in smaller chunks, including subwords and pauses. User has to select the formatted audio file that was generated in the previous step. Let's select it. This was an file generated by an interviewer, and also we have to specify the output folder. Since this WAV file belongs to an interviewer, I will choose this path. Of course, you can select different paths or specify different path, and then click segment button. It finishes immediately, as in the extract and format audio function. We will perform segment audio function twice. One for an interviewer that we have already performed, and one for an interviewee. This time I will select an interviewee folder and select one file belong to an interviewee, and again click segment button. It finishes immediately. I want to show you the output. Audio segments. This all are segments of an audio, and a text file are generated. In a text file, time span of each segment. This is the number of segment, and this is an interval of a segment, and this shows length of a segment are presented, as you can see here. And this is the last file, and this is the last line representing the segment ID and the interval of a segment. Now we can run the third step, time interval estimation. This panel can be used for performing two objectives: time interval estimation of an experiment session and synchronization of pair recordings. In an experiment, starting time of recording most probably doesn't correspond to the starting time of an experiment, or similarly, the ending time of an experiment may not be the moment that you stop recording. So we should try to determine exact time interval of an experiment and only analyze data during this interval. Once the automatic segmentation is completed, a human annotator must still listen to audio segments to specify the first and the last segments of an experiment session. If you start an experiment session with a distinguishable bleep signal like that, you can easily identify initial segment, and it will make your job easy. This panel is also necessary to provide synchronization of participant pairs recordings. In particular, recordings from different sources have to be synchronized to conduct synchronous analysis in a direct conversation setting. If you have two recordings and if you already specify the initial segments of each recording, Magic calculate the time offset to provide synchronization according to the time difference in starting time between the two recordings, and that way provides synchronization. As you can see, this panel provides an interface for either a single participant or a pair. Firstly, again, we have to specify the output file. If the button name is create or load, this means that you can create a new file or you can load the existing file. This time it will append the generated text at the end of the existing file. In case of a single participant, user is expected to enter the unique ID of the participant, select the segments interval file which is generated in the previous step, and also user has to enter the experiment interval by typing the name of the first and the last segment. In case of pair selection, we will enter unique ID again. I will give one. As an ID, and also we will have to enter segments interval and experiment interval intervals for both participants, for the first participants for an interviewer in our pilot study and for an interviewee. One segments interval is generated in the previous step and it is saved under this, and this is the file. We can open it. And to determine the experiment interval, we have to listen the generated segments. Since I have already listened them, I know the initial segments. I want to listen. This is the initial segment for an interviewer, and name of it is 7, so I will enter this. And since I listened before, I decided this was the ending segment. It's in Turkish, but an interviewer saying here, okay, thank you for your participation. So I decided this was the last segment of an experiment, and I will also enter its name. Then select the segment interval file of an interviewee. This is the text, and enter the initial segments for an interviewer. As you can see, this was the blip sounds, and again the same. When I listen the segments, I decided that this one also the ending segment. Unlike the single participant selection, a pair participant choice provide a resegmentation with synchronization info subpanel. After synchronization, the user obtains 2 recordings with the same length and processed in the same environment. A resegmentation function is provided to the user as an optional choice. Resegmentation aims at improving segmentation quality by merging information from different segmentation processes. This applies to situations in which each participant in a pair has his or her own microphone. The closer the microphone is to the participants, the cleaner and more accurate the audio recording becomes. The resegmentation process involves selecting a base audio recording, preferably the one who talks more. In our case, it will be an interviewer because he or she was replying questions, and end of this process it will generate a segments interval file and resegmenting the base audio recording based on the merge segments interval file. So it improves the quality of segments interval and segments data. Because of that, it's highly recommended to use this option. I will choose an output folder and then pair 1. This time I will generate a merged segments. That's why I don't use interviewer or interviewer name. Instead of that, I use pair 1 as a name of an output folder. Of course, you can select different paths. As I said before, in this pilot study, interviewee was replying to questions, so interviewers were talk more than the interviewers. So the base audio should be the second participant's audio, and I will also give that audio as an input, and then click Save and Resegment button. I want to show the output folder. As you can see, it generates the segments which is generated based on the merged information coming from both interviewer and interviewee, and also it generates a segments interval file, segments ID, starting time, ending time of a segment, and duration of segment. In the first line also there is information that represents the time of set between an interviewer and interviewee. This means that there is a negative time, which means the second participant, which is our based audio file, the second participant's audio started 4,590 milliseconds before an interviewer recordings. This is the end of a time interval estimation process. Now we can continue with the speech annotation. Speech annotation is the final stage of speech analysis process. This panel involves two subpanels, namely define speech acts and annotation. By using the define speech acts, user may select from a predefined set of speech act items, create a new speech act list, or user may update the existing list. Let's add following items as speech acts. Firstly, we have to specify the output file. Again, we can load the existing file or we can create a new file. Since this is the first time, we will create a new file under this path, and it will automatically assign this name into a file. I want to copy the speech X that I have determined before. Of course, you can use different speech X. It depends on your decision and on your experiments. Then we will click Add button. You can rename this by clicking on it, double clicking on it. A new window appear. For instance, you can make this name as this. It will change the existing name, but I will change it back. Let's add the other for the remaining speeches under the same output file. So I won't change this part. I will just add speech, enter speech X and click the add button to add new speech X. Ask question, greeting, confirmation, questionnaire filling, free speech, read question, love, and signaling and of speech. You can change the order of speeches by using these icons. For instance, we can make it the last option. So after we finish to enter all of the speeches, we have to click the save button. When we look at the output folder, this file is generated, and if you open it, you will see that it writes the speeches in the order as you specified. So we can continue with the annotation. This panel provides users to annotate segmented audio files with the predefined speeches. For this, user has to upload the list of speeches and also load the audio files and load the segments interval of the loaded audio files. The interface also embeds a media player control to play the audio file. There is also a field displays the audio time in milliseconds, as you can see here. The annotation process involves listening the audio file and select the appropriate speech act with the speaker identity. If you couldn't decide the speaker or speaker information isn't necessary, you can also select empty choice. Let's try this annotation function. we have to again create or load output file. Since this is the first time, we will create it speech annotation name is automatically given to the file. Since we resegment the audio files in time interval estimation process, we will use those audio files with their segments internal text, and also we will load the speechx that we have defined in the previous panel, subpanel. These are the speech lists. To listen the segments, you can press the play button. I think this is there isn't any speech. This is a pre-speech of the first part interviewer, so I choose this one. And you can click annotate button or annotate and play next file button. Since annotate and play next file button make your process faster than the first button, I prefer you to use annotate and play next file. It will automatically add the text involving interval of the segment in millisecond, speaker and the speechx, and also play the next segment. Suppose that it was this, and also this was. So you can annotate until the end of the intervals. And also there is an option to add subsegments, because the output file is an editable area, so you can edit the text in this area. For instance, if you think one of the segments that you play is related with multiple speechx, you can divide it into multiple rows by specifying each inner segment's interval. To do this, you can play the audio file, and then by using the field displays the audio time in milliseconds to specify the each inner segment's interval. For instance, we can add a new line instead of press speech. We might say there might be love, and we can decide the interval by using this field and starting, ending, but these two are the inner segment of the zero segment with the zero ID. Let's say the first subsegments interval and in this time, and so the second subsegment start this time, and this is the end of the second subsegment. After you finish to annotating each audio file, you have to click save button. If you couldn't finish annotation in a single session, you can save, and then when you come back you can load the existing file. It will automatically append the text where the cursor is located. So save the annotated segments. Let's see the output file. This generates an output file with this name in this path. This is how it looks like. So this is the end of the speech analysis module. Please feel free to contact us if you have encountered any problems, and don't forget to watch the other videos to learn about remaining analysis.